So far, you guys have learned how to graph quadratics in both vertex and standard form. Today, we're going to talk about how to graph an intercept form. So it's called intercept form because you can easily find the x-intercepts of the graph by setting those factors equal to 0 and solving. So you don't need to worry about the a value in front. We're just going to set each of those factors equal to 0 and solve them like we did when we were factoring. And then we need to find the vertex. So remember, in both of our other forms, finding the vertex is the most important thing that we need when graphing a quadratic. So to find the x value of the vertex, we are going to find the x value in between the two x-intercepts. So we're going to basically have our two x-intercepts. We'll count into the middle to find where that x value is that's halfway in between them. That's the x value of the vertex. So then to find the y value of the vertex, we're going to plug in that x coordinate that we just found, that middle point between the two x-intercepts. We'll plug that into the equation for both x's, and that will give us the y value of the vertex. Then, based off of that, we're going to graph our vertex, our x-intercept, and then our remaining points using our 1, 3, 5 pattern. So let's take a look at an example. So in our first problem here, we are going to start by taking both those factors and setting them equal to 0. So I will have x plus 4 equals 0 and x plus 3 equals 0. So one of my x values will be -4, one of my other x-intercepts is -3. So if I graph both of those on my graph down here, I'm going to go to my x-axis and I'm going to put a point at -4 and one at -3. So halfway in between -4 and -3 is -3.5. That's the x coordinate of our vertex. Then we're going to take that -3.5 and we're going to plug it into our equation for both x's. So I will have 3.5 plus 4, sorry, -3.5 plus 4 and -3.5 plus 3. So that will end up giving us -3.5 plus 4 is a half, and -3.5 plus 3 is -1/2, so we'll end up getting -1/4. So I'm going to go ahead and plot my vertex then. So I'm going to go to -3.5 and then just go right below the line there. That's at -1/4. And then my a value here is 1. So in the very front there, I technically would have a 1 there. So my pattern is going to stay my normal 1, 3, 5 pattern. So when I start at my vertex, since remember I'm at -1/4, so if I go up 1 over 1, I'm really going to go just right below +1 there. That would be kind of up 1, and then I'm going to go over 1. So remember I'm halfway in between as well. So I'm going to end up right about there. And then same thing on the other side. And then from there, I'm going to go up 3 over 1. Okay, and then I can also do up 5 over 1. Then I will connect all my dots. And I have my graph. So the other thing that we're going to talk about on our graph is both our domain and our range, and then also our intercepts, which some of them we already found. So if we look at our graph here, our domain is all of our x values. And if you can see on my graph, since it's going to continue to go up forever, it's going to go left and right forever as well. So our x values are going to be all real numbers. For my y values, you can see it doesn't span all y values because I have a point here at the bottom, that vertex. Nothing goes below my vertex. So that means I can have every single y value that is -1/4, since that's the y value of my vertex, and above. So y is greater than or equal to -1/4. Or if you do write in interval notation instead, that would be negative 1/4 with a bracket to infinity. For my intercepts, we actually already found our x-intercepts. Remember, they are -3 and -4. So I'm just going to write them as coordinate points. So I'll have -3, 0 and -4, 0. And remember, to find the y-intercept, we're going to plug in 0 for x. So I'm going to go back up to my equation, and I'm going to plug in 0 for x, and I'm going to see what I get for my y value. And that will give me 12. So my y-intercept is 0, 12. All right, let's take a look at another example. So on this one, again, I'm going to set both of my factors equal to 0. Remember, I don't care about the a value, so I'm not worried about that -2 in front. I'm just going to set x plus 1 equal to 0 and x minus 3 equal to 0. So I will get x equals -1 and x equals 3. So I'm going to go ahead and plot those on my graph. So then if I take a look at my 2 points here and I count into the middle, you'll notice my halfway point between them, the x value is 1. So +1 is the x coordinate of my vertex. Then remember, to find the y coordinate of my vertex, I'm going to take 1 and plug it into my equation for both x's. All right, so 1 plus 1 is 2. 1 minus 3 is -2. So 2 times -2 is -4. Times this -2 is -8. So my vertex is at 1, -8. So I'm going to go ahead and graph that. You'll notice this is a much prettier graph since we don't have all those fractions. So then for my pattern, you'll notice that my a value this time is -2. So that means that my pattern then is going to, instead of being 1, 3, 5, it's going to be -2/1, -6/1, and then so on if we need to keep going. And I'm going to back up here for a minute. I notice I just made a mistake. My vertex here should be a +8 because when I went and plugged in y, it's -2 times +2 times -2, which would be a +8. So I'm going to change this to +8. Sorry about that. I'm also going to move my vertex here on my graph up to +8. All right, so now you'll see I can go down 2/1 in both directions, and I can go down 6/1 in both directions. And then after that, keep in mind it would be, instead of 5, it'd be -10/1. So I can go down 10/1 as well. And then I will connect my dots. And there's my graph. So let's go below and go ahead and answer those questions down there as well. So if we look at our graph, you can see even though my graph is facing downward instead of upward like the first one was, my domain is still all real numbers because as my graph goes down forever, it also goes left and right forever. So I cover all x values. For my range, you'll notice it does not span all y values. I have to worry about that vertex. So my graph goes down forever, but it goes when it goes up, it stops there at that y value of 8. So you'll notice 8 is the highest y value I can have, and I can do anything below 8. So my inequality will be y is less than or equal to 8 this time, since it's facing downward. In interval notation, that would be -∞ to 8 with a bracket. For my intercepts, remember we already found our x-intercepts. So our x-intercepts were -1 and +3. So I'm going to write those as coordinate points. And then again, for my y-intercept, I'm going to plug in 0 for x in my equation. So let's see, it was x plus 1, so 0 plus 1, 0 minus 3. And that will give me positive 6. So my y-intercept then is 0, 6. And you can see, since that one actually fits on the graph, you can actually see it up here on the graph. There is a point there at 0, 6. There's your y-intercept right there. All right, so that is how you graph an intercept form and find some additional information from the graph.